Now this question says OAB is a triangle. Okay, OA is equal to A and OB is equal to B. OA is A and OB is B. Then A says find the vector AB in terms of A and B. Find this. Okay, now P is a point on AB such that AP is to PB is equal to 3:2. AP is to PB is equal to 3:2. Okay, show that OP equal to 1/5 is to 2A plus 3B. Okay, and this will take us to a topic I titled vectors. Now, what is a vector? A vector is a quantity that has both magnitude and direction. Okay, so it has magnitude and then it has direction too. Okay, if a quantity has magnitude and it has direction, that's the only thing that qualifies it for us to call it a vector. Now, there's another quantity type that we call scalars. And what is a scalar? It's just a quantity that has magnitude alone. Okay, now let's imagine that this is a vector AB. Okay, now this is a vector because it has magnitude of AB and it has direction from A to B. Okay, that's why it's a vector. Okay, now having said this, now how do you know whether to call it AB or BA? Now, if the arrow is directing you from A to B, that means it's vector AB. But if the arrow was this way, that means it's vector BA because it's directing you from B to A. You can have positive and negative vectors. Vector AB is the same thing as negative of vector BA. Okay, now negative in the sense that it's the same magnitude but it's a different direction. This negative signifies the direction. Okay, now but we normally express this in the particular quantity of BA. For example, if AB was A, okay, and BA was B, okay, now AB, which is A, and BA, which is B, therefore A will be minus B, okay, or B will be minus A. Now this is the quantity part of this vector, or this is the vector as in the main vector. Okay, now when we say vector AB and we call it a name, this is what we'll refer to it in form of the quantity. Now, going back to the question, we were told that OA is A and OB is B. Okay, now I want you to look at the directions. If it's OA, that means it's O heading to A, and if it's OB, it's O heading to B. Okay, now this leads us to something else too I want to talk about. Now, if you have AB, A heading to B, okay, and you have BC, B heading to C, okay, now if you want to go to C now from A, you'd either go from A to B, then B to C, or you go straight from A to C. Okay, if you want to get to C from A, now look at it, it's either you go from A to B, then B to C, okay, or you go from A straight to C. Okay, so in vectors we always say that this is the resultant vector, of A, B, B, C. Okay, in other words, it's written this way: AB plus BC is equal to AC. Okay, Now at all times, if this was this arrow now, we can't say that this is equal to this. Okay, we can't say AB and BC will be equal to AC. No. Okay, it will always be that AB and BC, taking it from the direction point of view, is either you get to AB then B to C, okay, or you go straight from A to C. Okay, now that's referring to A, now taking A as starting point. Okay, now let's use this and talk about this question that we're given. Now given this question, now we're told that OA is A and OB is B. AB, now you can't say AB. Okay, we are told to find the vector AB in terms of A and B. We can't say that AB is the resultant, since AB is A heading to B and it's going to be like this. Okay, remember, this is more like OA. O is the starting point and the ending point is B. Okay, now if you want to get to B, or let's take this as our resultant now. Okay, if you want to get to this, is either we'll now say we want to get AB, then we'll now say okay AO. Okay, then from AO we'll now say AB. We'll change our starting point. Instead of O, we'll start from A. Okay, we'll now say okay, let's start from A, since we're looking at this now as resultant. Okay, we'll start from A. We'll now say from AO we'll get to O first, then from O we'll now get to B. Okay, now it's either that or you now go straight from A to B. Using this kind of explanation, you'll be able to resolve resultant vectors very well. Remember, they told you find the vector AB in terms of A and B. Okay, now AB in terms of A and B, AB means that B is the end point, so at all times you have to ensure that B ends it. So that means AB has to be the resultant vector. Okay, AB being the resultant vector means that it must start at A and end in B, no matter what you do. Okay, now for this thing to start at A and end in B, we have to start from A and get to O, and O to B. It's more like saying which other way can we get to B from A. Okay, so the other way we can get to B from A is just to go from A to O, then O to B. Okay, then that means from what we were taught earlier, it's AO, vector AO plus vector OB. That will give us vector AB, and it's this vector that we're looking for. But ordinarily we're given that OA is A. Okay, but vector OA is A and vector OB is B. So seeing that OA is A, okay, AO is the reverse of OA, so AO will now be minus A. Remember what I said earlier, that we can actually negate the value of AO, okay, if the direction is different. This negative means that OA is in the opposite direction of AO, though they are the same magnitude. Okay, now having that in mind, we can now say AO plus OB is going to give us AB. Okay, now that means since AO is negative A plus OB, we're given already that is B. Okay, that means AB is now going to be B minus A. Okay, now let's go through this once again. AO plus OB equal to AB. Now how did we find it? We found out that from what we're told that the resultant vector, we're told to find vector AB. Now we're told to find the vector AB. Okay, now that's how we knew that we have to start from A somehow and end in B somehow. So whenever they give you a question, look for the resultant vector that they're asking you to find. Okay, that will show you where they want you to actually start and where they want you to stop. Okay, now saying AB is the resultant vector, that means they want us to start from A and stop in B somehow. So apart from going from A to B, which other way can we get through and be able to get to B from A? Okay, now that's how we now got AO from OB again. That's going this way and going this way. But since we were given OA as A. Okay, this is more like the direction is this way but the same magnitude, but we want to change the direction. That means this value is going to be negative now. Okay, now that's how we got negative A for AO, but OB is the same. Okay, that's how we have B for it, and then the answer for AB is going to be B minus A. So we're now told on this question again that P is a point on AB such that AP is to PB is equal to 3:2. That's AP, this is 3, is to PB, this is 2. Okay, now show that OP is equal to 1/5 bracket 2A plus 3B. Now let's find OP. Now they're not asking us to find OP as resultant vector. Okay, now finding OP as resultant vector, we now know that we have to start from O and end in P somehow. Okay, and end in P somehow, even if the direction wasn't there. So it's either we go from OA, okay, and now get to AP. Okay, OA AP. Okay, now OA is already given. Now let's write that down. OP is equal to OA plus AP. Okay, now we have OA already as A, okay, plus, but we don't know AP. Now they gave us an interesting combination now, that 3:2 is a combination of, that's the ratio of AP to PB is 3:2, so the total ratio is 5. Okay, now we already know that AB is B minus A. Okay, that's the first answer we got. B minus A is AB. Okay, so we know that AB is B minus A. Okay, now AP, A heading to P. Okay, the same direction. Now the magnitude is going to change. We're told that it's 3/5 over the total of 5. Remember that we're told that this is AP is 3 and this one is 2. So we're looking at the ratio of everything. Total is 3 plus 2, that's 5. 5 representing B minus A. Okay, now the ratio of AP is going to be 3/5 into B minus A. Okay, AP is 3/5 into B minus A. Now how did you get it? Let's go through it again. We're told that AP, the ratio is 3. The ratio of AP to PB is 3:2. That means that the total ratio here now is 5. But we already know that AB, the total ratio is AB. Remember, now we already know that AB is B minus A from our first calculation. Okay, now the ratio of AP when you're combining it to AB is going to be 3 over the total times AB. Okay, that's 3 over total times AB. But we know that AB is B minus A. That's why we substituted. So we have that your AP is going to be 3/5 into B minus A. So our OP is now going to be OA. OA is our A, okay? Then plus AP is now this 3/5B. This times this is minus 3/5A. So OP is now going to be A gathering like terms minus 3/5A plus 3/5B. Now our OP will now be A minus 3/5A is 2. That's this is like the same thing as saying 5/5A minus 3/5B. 5 minus 3 is 2. It's going to be 2/5A plus 3/5B. OP will now be, remember, this is more like what's common in both of them is 1/5. So you have 1/5 into factorizing, you have 2A plus 3B. Now we've successfully proved that OP is the same as 1/5 into 2A plus 3B, and that's what we have here. Okay, they said OP is 1/5 into 2A plus 3B. We were so told to prove it. Now we successfully proved it. Now the basic thing about these vectors is just know your resultant vector. Your resultant vector, the first alphabet tells you where to start and the last alphabet tells you where to stop. with that in mind, you'll be able to solve all sorts of vector questions. So that's it for vectors.